stack pointer will pointing to Z node, my input symbol will be C. So what should I do? I have to push C inside the stack. So whatever may be the number of C's, I have to push C inside the stack. After a period of time, so you'll be familiar directly constructing the push-down automata, right? So even this manual thing is not required. So direct construction you'll be familiar with. Okay. So C, I have to push inside the stack. So next comes if suppose I am having a D and my input symbol, stack symbol is C. So please make a note over here. Z naught C C C. So here D, here C. So what should I do? I have to perform pop operation. Yes. So whatever may be the number of C's, I have to perform pop operation. So at one point of time, what happens? All the stack elements will be popped up. My stack pointer will be pointing to Z naught. And if it is in a proper pattern, I'll be reaching the epsilon here. Okay, here epsilon, here Z naught. What should I do?
A final state.
Yes. Epsilon, Z naught.
Z naught, Z naught.
Final state. That is Q4. Okay. Right. Okay, ma. This thing I think we can see it in the next. If
I'm in Q2, it should be CCCC, right? In short, we have to push C.
Thank you, ma'am. C, I have to push C. Okay. The rest is correct. Okay. We can continue with this in the next class. Okay. Because after a gap only we'll be proceeding with. So by that time you will forget everything. So we may not continue further. Just we can have a look into the topics of your CAT 2. Please make a note. Please do practice well for your CAT 2. Without practice, it is not feasible for you to get good marks. Okay. Because only with a glance of your notebook, it will not be good for you. So you will not have the familiarity. Only if you practice some exercise questions, you will get the familiarity. So please do proceed with, right? So just we can have a look into it. So what we have discussed just over here, we have discussed the optimization of the deterministic format automata, optimized TFA. Optimized TFA in the sense direct construction of TFA from the regular expression. So why we are calling it as optimized? So it is not when we are constructing TFA directly from the regular expression, then it is the number of states is going to be minimal one. There will be no need for going for minimization at all. Okay, so only because it is one of the optimization technique. Direct construction of TFA from regular expression is an optimization technique. So here, what is the first step? So first step in direct construction of TFA is you have to proceed with the convert. Yes, ma'am. Okay, what we have to do, so first we have to convert that grammar to augmented grammar. Augmented in the sense we have to add something. So what we are going to, so here why we are adding, so the reason behind us, we have to, so when we are constructing the NFA, all the we have to identify the important states. So what is important state? Non-epsilon outgoing transition will be considered as an important state. Here, the final state is an important one, which is not having any non-epsilon outgoing transition. So because of that only we are making it as an augmented grammar that is concatenating hash. This reason just we proceed with, so you can directly add the hash. That's it. Okay. The reason behind is this one. We are converting the grammar to an augmented grammar. This is the first step. So without augmentation, if you are constructing, then you will end up in a wrong DFA. So please make a note, you have to concatenate with the hash at the end. Next, what we have to do, we have to convert that DFA to a parse tree. That is for this for this regular expression, you have to construct the parse tree. After constructing the parse tree, we will be dealing with the four functionality. One is nullable, first position, last position, follow position. Okay. So while constructing the null position, first position, and follow position, we'll be making use of this table. Okay. Okay. I hope that is loading. Okay. Yes, we have to make use of this table. Here is in the case of nullable, if it is going to be a non-epsilon leaf node, right? If it is a non-epsilon leaf node, then it is going to be false. Okay. The thing is that you will get an expression where one of the node may be epsilon, that is epsilon or a. If a regular expression is like that, then in that case the leaf node will be having epsilon. Okay, that is what I am saying. If it is going to be a non-epsilon leaf node, that is A, B. So here you can see, right? So all these are non-epsilon leaf nodes, all the input symbols, right? If suppose here if I am having epsilon, then the nullable will be true. Okay, and then next comes the intermediate nodes. The intermediate nodes can have a combination of OR operator, clean closure, and concatenation. For concatenation, we'll be representing it by this. Okay, so for OR operator, it is nothing but nullable is nothing but nullable of C1 or nullable of C2. Okay, so any one of the, if it is true, then it will be true. Okay. Next comes the star node. Yes, star node by itself will be having, that is clean closure, right? So itself will be having epsilon, so it will be true. And for cat node, again it is going to be dependent upon C1 and C2. Only if both are true, that is C1 and C2. So here this cat node will return true only if both are true. Okay. So that is nullable of C1 and nullable of C2. And this is for nullable. And next comes first position if. So first and last is almost the same. So for first position, so the main thing is that each and every leaf node should be numbered. Non-epsilon leaf node should be numbered. Okay. So here we have to proceed with giving a unique numbering. Right. Here for first position, for leaf nodes, the number of that node will be the first position. Okay, if the number of the node is 1, then the first position of that node will be 1. Similarly, last position will be 1. For R node, it is going to be dependent upon C1 and C2. It is going to be union of first position of C1 union first position of C2. So it's similar to the thing for last position. So only thing is that you have to concentrate with the cat node. So here we are checking with the condition. So if the nullable of C1 is false, if nullable of C1 is true, then I will be going for taking the union. If not, I will be going for only the first position of C1. Okay, so this is for the first position of the cat node. Okay, and similarly for last position of cat node, so please see the difference over here. For first position, I will be checking C1. For last position, I will be checking C2. Okay, if C2 is true, nullable of C2 is true, then I will be taking the union of both the things, last position. Else, I will be going for last position of C2. Alright, and then clean closure is first position of C1, last position of C1. That's it. That is, clean closure will be having this node, right? This is what we are calling it as C1. So here, whatever the first position of this node, I will be having it here. Whatever last position of this node, I will be having it here. That's it. So that's it. First position, last position. level. So now comes the follow position. Here these three things we'll be computing for all the nodes in the tree, whether it is leaf node or intermediate node. For all the nodes I have to proceed with. For follow position, what we have to do is we have to proceed with only for the cat node and the star node. For follow position, we'll be finding only for the numbered leaf nodes. Okay, that is, we have to find follow position of 1, 2, 3, 4, 5, and 6. How we are going to find the follow position of 1? So, to find the follow position of 1, I'll be getting the help of the cat node and the star node. Okay, I'll be getting the help of cat node and the star node. So, what should I do? If that 1. So, for example, follow position of I am going to find. So, follow position of I, for example, follow position of 1. Okay, what I have to do is I have to check whether 1 is present in last position of C1. Here this is cat node, right? So for all the cat node I have to check. For all the star node I have to check. I will be checking whether 1 is present in last position of C1. For example, this is cat node, right? So this is C1. This is C2. If I am proceeding with finding follow position of 1, I have to check whether 1 is present in last position of C1. Yes, it is present. If present, I have to include the first position of C2. I am checking C1, last position C1, but what should I include? I have to include first position of C2 in follow position of I. So just please make a note of these things and you can easily work it out, right? And similarly for star node, what should I do? I have to check with whether I is present in last position of star. If so, I'll be including first position of star in follow position. I'll be checking last position, but I'll be including first position. Okay, and again C1, C2 also please do check it. Right. After finding the follow position, now we can start constructing the DFA. Right. So here what we have to do is the start state of your DFA will be the first position of your root node. This is our parse tree. This is the root node. For this root node, which is the first position, 1, 2, 3. So 1, 2, 3 will be the start state. Okay, so let me call that state as A. 1, 2, 3 together. I'm calling this as A. Then for A, I have to start marking. That is, for each and every input symbol, I will be marking. What should I do? I have to proceed with finding dtran of A, B and dtran of A, B, because I'm having only two input symbols here, A and B, so I'm proceeding with this. So what should I do? I have to check the positions of 1, 2, 3. 1, 2, 3. Right? So dtran of A, A. So here in 1, 2, 3, 1, 3 corresponds to A, right? Because I am proceeding with dtran of A, input symbol A. So 1 and 3 corresponds to input symbol A. So what should I do? Follow position of 1 union follow position of 3 will be giving my dtran. Okay. So again, as usual, I have to check whether it is an existing state or not. If not, I have to give a new state name. Right, like that I have to proceed till I am not getting a new state. After that I have to construct the transition table and then I have to proceed constructing the transition diagram, that is the DFA. Okay, that's it with minimized automata. Next comes the pumping lemma. Yes, using these set of rules you can very well proceed with finding. So here in the case of pumping lemma, you have to prove whether the language is not regular. So you cannot say that the language is regular. The only choice is to prove that the language is not regular. Language will be given. For that you have to prove that it is not regular. Okay. Yes, next we discussed the closure properties. Already the materials for pumping lemma I have shared. Okay. Closure properties, yes, you can deal with. Yes. Yes. designing the grammar. Please make a note, try working out examples, okay? So here, grammar already we have discussed. These are the tuples of grammar, okay? Here, if we talk of grammar, this is the sentential form, right? So this is the sentential form. Yes, if I am dealing with deriving from the leftmost non-terminal, okay? So this is the leftmost term and this is the rightmost term. Okay, so if I am reducing it from the leftmost non-terminal, so here in this case what I am doing, so this is the leftmost term, right? So this leftmost term I am reducing it, so this is leftmost derivation. If suppose I am proceeding in this way, this is rightmost derivation. So please make a difference, see the difference over here. Either I can yes, derives A as B. Either I can reduce the symbol first. So if I started reducing this, I can either scan this way or this way, okay? So if I'm scanning in this way, then it is going to be leftmost. If I'm scanning this way, then it is going to be rightmost derivation, okay? The end thing is that I have to get the string that belongs to that language. That's it. Yes. Here for this language, if I am supposed to design a grammar, if I want to construct a grammar, what should I do? This is the simplest form of representation. That is, yes derives, it can derive. So this is a finite language, so I can easily write the grammar like this. That is, S derives A or AB or BA or B. But if it is going to be infinite one, I have to give it in a generalized way. So even this I can proceed with giving it in a generalized thing. So what I can do, so what is AA, AB, BB, EA, BB? So it is nothing but A or B concatenated with A or B. Okay, so what I can do is A or B is represented by one non-terminal. So this non-terminal is repeated twice. Okay, so that is A derives A or B. A derives A or B. This A is going to be repeated twice. That is what we have constructed. Next comes A bar n. So here A bar n, the n is greater than or equal to 0. So here you have to check with the condition. Okay. So here what is the thing? So there is a possibility of epsilon even, because n is greater than or equal to 0. Okay. So what we can do? So for yes. So this I can either have a choice of epsilon, or I can have this A needs to be repeated n number of times. This A needs to be, so I can have epsilon 1A. So for example, if I want 1A, what should I do? So for this A, I have to replace it with epsilon. Then I will be having 1A. If I want 2A's, what should I do? For this A, I have to repeat A, right? So like this, I'll be generating the string. Yes, this comes A or B. So these are the simplest thing using which we have already discussed the grammar. Okay, so these are the basic things which we should be familiar with. Here next is A or B star. What is A or B star? Epsilon A, B, A. So any number of times A or B can be concatenated in any pattern. So there is no sequence. So A and B can be repeated any number of times. That's it. So after A, so here what is the thing? Epsilon is possible. So epsilon is included. After A, I can have any sequence of A's. Alright. And similarly, I can have any sequence of B's even. So that is what we are having. A concatenated with S and B concatenated with S. So what can I do? I can have any combination of A's and B's, and I can even have epsilon. Next comes a set of all strings of length at least 2. So if you are given with a condition of at least 2, so at least in the sense mandatory string is 2. So for that I have to represent by this. Okay, A or B concatenated. So here all these things we have considered the input alphabets as A and B. Okay, so I have to. So what are the minimum possible string? A, AB, BB, B. Okay, so for that I will be having this expression. After that I can have the strings of any length. So this is A or B star. For this representation, we have already constructed, right? S derives. So what is this? So S derives AA will generate this one. A derives AR. Okay. So now what is the sequence required? This sequence needs to be concatenated. So for that, we are introducing a non-terminal where AB or BB or epsilon, similar to this one. Okay. So B is concatenated. Next comes strings of length at most 2. So here at most, that is, I can have epsilon, I can have one string of length 1 and I can have string of length 2. The maximum string length is 2. So here what is the thing? So A or B or epsilon, A or B or epsilon. Okay, so that is going to be represented by one non-terminal and then it is going to be concatenated, repeated twice. AA, that's it. Yes, the next one starting with A and ending with B. Okay, so in between I can have anything. Okay, in between I can have anything. So how we can represent it? So for A or B star, I am having the sequence. Okay, this is the production which generates A or B star. And then what should I do? I have to, in front I should have A, at the end I should have B. So this is the representation. A, B. Okay, next is starts with A and ends with B or vice versa. So here, yes, the same thing. Here, the additional thing is I can take even vice versa as well. If it starts with B, I should end with A. Okay, the same thing we have introduced B, A. So only simple modification, that's it. Next comes starting and ending with the same symbol. So here, different symbol. Okay. Whereas here it is same symbol. So what is the possibility? I can even either have strings of length 1. Okay, so that is A is also possible because starts with A, ends with A, starts with B, ends with B. So here yes, AA, BA, epsilon. So in between I can have anything, right? So that is what. So A or B star, for that expression we are having this production. The next thing is I have to, in the start I should have A, at the end A. If it starts with A, it should end with A. If it starts with B, it should end with B. Okay. So, and then considering the same symbol, we are including this one. That's it. Okay. The next comes. Yes. Are you clear with this? Any doubts? Any specific doubts here?
No doubt, ma'am.
Oh, that's good. Yes, I hope we can move on. What is this? Yes. Next is Chomsky normal form. So here in Chomsky normal form, yes, we have derived the leftmost derivation, rightmost derivation. One example is here. Okay, you can make use of it. Yes, next is Chomsky normal form. So what is Chomsky normal form? So productions can have two non-terminals or only one terminal symbol. So before proceeding with Chomsky normal form, we have to eliminate the grammar. For elimination, it involves three different steps. One is eliminating the symbol, eliminating epsilon production, and eliminating the unit production. Okay. Yes. So this is the same order for simplification. So if we are doing it interchangeably, what happens? We will be in a position to repeat the same sequence of steps. Okay. So in order to avoid that only, we are proceeding with dealing with the safe order. So what is epsilon production? Yes. Here. So what is epsilon production? So yes. T derives epsilon, U derives epsilon, W derives epsilon, right? So this is nullable. So T, U, W or nullable. So T, U, W or nullable. So what happens? V derives W. So again V is also nullable. And again S derives B, S is also nullable, right? So here all the non-terminals are nullable, so we have to address this. So while simplification, we have to make sure that the mean of the grammar is not changed. Okay. So while eliminating epsilon and unit production, we have to be careful that the meaning is not changed. So how to eliminate the nullable? So here, S derives TU or B. So what is the possibility? So if T is nullable, I'll be having U alone. If U is nullable, I'll be having T alone. That is what we are having. T, U. So original production we have to retain. And if this U is nullable, I'll be having T alone. If this T is nullable, I'll be having U alone. And as usual, the regular production is okay. Next time production is T derives A, T, B or epsilon. Epsilon we have to remove it. So what is the possibility? If T is nullable, I'll be having A. Okay, similarly U derives U or epsilon. So here in this case, if U is nullable, what I'll be having? I'll be having C. Okay, this is how we'll be eliminating the unit production. Sorry, what is that? Epsilon production. Okay, and next coming is eliminating the unit production. Yes. Here, what are the unit productions here? S derives T, S derives U, S derives V. And another unit production is V derives W. Okay, so these are the unit productions. So if I have to eliminate it, what should I do? Productions of T should be placed here, productions of U should be placed here, productions of V should be placed here. Again, V is having a unit production. So what should I do? First, I have to eliminate this. Productions of W should be placed here. What about the productions of VW or that is what we have placed here. Okay. So instead of W, productions of W are placed here. Okay. Now we can move on here. So in order to eliminate S derives T, productions of T should be placed here. So these are the productions of T that is placed. And then productions of U are placed here, and then productions of V are placed here. So this is how we'll be eliminating the unit production. And next comes eliminating the user symbol. Yes, so what is user symbol? So non-reachable and non-generating symbols are non-generating and non-reachable symbols are user symbol. So what is non-generating? So non-generating in the sense all the productions all the user symbols will have productions. So if it is going, if any of the productions is not having any productions, then it is going to be a user symbol, non-generating symbol. Okay. And another thing, non-reachable. So what is reachable first? So all the user symbol. All the symbols should be reachable from the start symbol. Okay, all the symbols should be reachable from the start symbol. So if it is not reachable, then there is no use of that particular symbol at all, right? Okay, that is what non-reachable is. So here we can have the example here. Yes, this is one production. So here you can see there are three non-terminals, S, A and B. Among these three, B is not having any production. So B is a non-generating symbol. How to eliminate it? The user symbol, the productions which involves the user symbol can be completely removed. We will not worry about that, bother about that. The productions that involves the user symbol can be removed. Here you can see AB. Okay, so this can be removed. So this production is having B, which is a non-generating symbol. So this can be removed. After removing, I'll be having this production S derives A and A derives B. Now I have to check for non-reachable symbol. Yes, so from start symbol, is A is reachable? No, it is not reachable. So it is a non-reachable symbol. So this can be removed. So finally, I'll be having only this production. Okay. Yes, so if we talk of this grammar, here you can see I'm having 5 non-terminals. All the 5 non-terminals are having the productions. Okay, and similarly here you can see ST is reachable from S, U is reachable Yes, and yes, here even B is also reachable, W is also reachable. It is not mandatory that all the symbols should be reachable from this one. Either it should be reachable from any of the all the non-terminals should be reachable from any of the reachable symbols. That's it. Okay, hope you can understand. Yes, here in this example we can see X is reachable from S, right? And Y is reachable from X. So yeah, all the symbols are reachable from the star symbol, right? That's it with the charms. Yes. After simplification, we have to proceed with converting the grammar to Chomsky normal form. So yes, what we have to do is we have to convert the grammar to, so this is the simplified grammar. This simplified grammar need to be converted to Chomsky normal form. How to convert? We have to introduce some additional non-terms. Okay, so what is no non-terminal should be there, or only one terminal symbol should be there. Wherever there is deviation, we have to make the appropriate corrections, right? So here there is deviation, right? So in that place, I am going to introduce a non-terminal. So okay, instead of A, I am going to introduce BA. Okay, and instead of B, I am going to introduce BB. Like that, we have rewritten the productions. Okay. And then again there is deviation. So four non-terminals are here. So what I can do is either you can club these two as one non-terminal, club these two as one non-terminal, and you can proceed with. Here in this case, these three are considered as Q1. After that, these two are considered as Q2. Okay, so these three are clubbed together. That is XPBX, and PBX is clubbed as X2. Okay, this is how we have reduced. We have converted into Chomsky model form. And here EA, yes, this one should be reduced. Okay, so this is changed to Q3. Q3 derives XPB, and here PA Q2, where Q2 is PBX. Okay, so this is how we will be converting the grammar to Chomsky normal form. Next, Grigbax is we have seen this now only, so you can recollect it. Okay, so here we have to convert the grammar to this form. Okay, so the main thing is first we have to proceed with renaming. So while renaming, you have to give it in a sequential number. That's it. That is an ascending order. You have to number it, right? And then after renaming, you can rewrite the production, and then you have to check for the condition. So if it is going to be greater than or equal to J, then I have to make the appropriate updations. What I have to do, if it is going to be I is greater than J, okay, here in this case I is greater than J, so what should I do? Productions of A1 should be placed here. That is what we did. Okay, and again I is greater than J, so productions of A2 is placed here. Okay, this is the case for I greater than J. If I is equal to J, then we will be coming across the precaution, left precaution. Okay, so using this rule, we can easily eliminate the left precaution. Yes, that's it. Any doubts from your side?
No, ma'am.
Okay, please make a note. Please do attend all the questions, right? Please do attend all the questions. Yes, already in the these marks will be included in your fact that you all aware of. Here, the last Cat 1 itself, the class average was around 17. So please do improve your marks. Okay, only practice. So just practicing, you can easily score the marks in the subject. So please do practice it. I have given you a few. For each and every topic, I have given one questions only for assignment. So, but please do practice more questions. Okay. That's it. Prepare then for your exam. Do well your exam, and happy Diwali, because we'll be meeting after Diwali only. Okay. That's it from my side. If you have any queries, you can please do ask me.
Thank you.
Thank you.
Thank you.
This video in team. If you want, you can refer it. Okay. Thank you. If you have any queries, you can please stay back, or else you can leave. Thank you.